Okay, example 21 is really not any different than example 20. We're looking for the delta H for this reaction. The difference between the two is that I have ions and not just elements and compounds. Still going to take the sum of the products. So 1 times CO2 gas plus 1 times H2O liquid. So that's the sum of the products minus 2 times H plus aqueous plus 1 times CO3 carbonate ion aqueous. Okay, so again we have products. There's 1 CO2 and 1 H2O. 1 times CO2, 1 times H2O. Remember, states of matter are very important. 2 times H plus aqueous plus 1 times CO3 aqueous. And now we're going to find that sheet to look up those. Okay, so 1 times CO2 gas, so we're going to look for CO2 gas in our sheet. We're going to look in the carbon. CO2 gas, CO2 gas. CO2 gas here, negative 393.5. So 1 times negative 393.5 plus 1 times, I'm going to look for hydrogen. H2O liquid. H2O liquid was negative 285.8. We use those a lot, those two, if you noticed. So negative 285.8 minus 2 times H plus aqueous, or hydrogen ion aqueous. So that is going to be H plus aqueous is 0. So we're going to go back in and put 0 in for that. That's not an element, so you wouldn't know that was 0 without looking it up. Plus 1 times carbonate ion. So we're going to look in the carbon section. Let's see, CO3 aqueous is negative 677.1. So this will be negative 677.1. So now we're going to do this math and then subtract the 2. I get negative 679.3 for the product side, minus negative 677.1. Subtract those two, and I get negative 2.2 kilojoules. Something to point out here, where do my students make mistakes? You make mistakes by flipping these, and then everything is wrong, I can give you no credit. You have to put last goes first, so the products go first, and first goes last, so the reactants are at the end. So you start with your products, sum those, subtract the reactants. So be very careful with that piece.